Okay, so I've got 4 times x plus 3 squared minus 12 equals 388. What should I do first here if I'm trying to solve this equation? What's the very first step you would do? Plus 12. Okay, plus 12. All right. 4 times x plus 3 squared, 400. Okay, what do I want to do next? Will be my next step. Colton, what do you think? Divide by 4. Okay, don't distribute, divide. All right, so I've got x plus 3 squared is equal to 100. Okay, do I want to FOIL? Like, what do I want to do next? Square root, don't FOIL. Please don't FOIL. This is what you want. This is glorious for us. If we've got parentheses that are squared, guess what? We can cancel them out. As long as they're alone, we're just going to take a square root. Don't FOIL. Don't make more work for yourself. Just get rid of it. And I'm writing too big, so I'm going to come over here. Now, x plus 3 squared in the parentheses there, when you take the square root and squared cancel each other out. You still have the x plus 3, but you could just drop the parentheses. The other side of the equation, what would I write for square root of 100? What symbol do I have to put in front of it? Plus 1. Okay, I'm just making sure. This, when you guys, you got to remember this. If you introduce the square root into the problem, right, you actually have 2 answers to that question. It's positive 10 or negative 10. That plus minus is just the shorthand way of writing it. Now, this is a really good example here. So I got to get x alone, very similar to the homework problem we were just looking at. But when I do that, I'm going to write that negative 3 just right after the equal sign, plus or minus 10. Now, if that 10 has an I attached to it, we're done. If that 10 has a radical attached to it, we're done. If that is just 10, we're not done because you can actually add and subtract. So if I do negative 3 plus 10, I can actually add that, right? So that's going to be 7 as one of my answers. Negative 3 minus 10 would be negative 13. If you just wrote negative 3 plus or minus 10, I'd have to take a point off on a test or quiz because we can actually take that a little bit farther to simplify. Like I said, if the 10 has an I with it, we're done. If it has a radical with it, we're done. But in that case, if it's just a 10, then you can actually go a little bit farther. Is anybody having a question? Okay. What we're going to work on today is another method for solving quadratics. So we've done factoring, we've done square roots, we've done graphing. Today we're going to do a method, it's called completing the square. And you guys might want a calculator for a couple of problems today. It doesn't have to be a graphing calculator, but we're going to be working with fractions in just a couple of the problems. So if anybody needs a calculator, you're free to grab one of mine or go ahead and get yours out. But we're going to talk about completing the square, which hinges on you having a perfect square trinomial in the question, which we may have to create to do the problem. So we're just going to talk about these real quick. So I just have 2 examples. These are not equations, but they are perfect square trinomials. So I'm going to see if you guys could factor these just as a little review. So if I had x squared plus 10x plus 25, just tell me the 2 little sets of parentheses, the 2 little factors. What 2 numbers for this one? I would have 2 numbers multiply to get me 25 and add to get me 10. Can you think of 2 numbers when you multiply them together, you get 25, same 2 numbers, you add them together, it would be 10. 5 and 5, yes. Okay. Now, x plus 5, x plus 5. What is another way I could write that? Yes, yes, yes. Okay. That is a perfect square trinomial. That is when what's going on here, both factors are the same. Now, when both factors are the same, that allows you to squish it together and write it as that factor squared. So that's what we want in these questions today, because that's going to save us from having to FOIL or box or something like that. We're just going to have a set of parentheses and then we'll take a square root. Now, what about if I gave you the question right next to this? This one has x squared and it's a minus here, 14x plus 49. Can we think of 2 numbers? When you multiply them, you get 49, but when you add them, you get a negative 14? It's got to be 7. They're just both negative. So this would be x minus 7, x minus 7. The factored form, because they're both the same, I can go ahead and squish them together, write it as x minus 7 squared. I just wanted to make sure you guys knew it was okay. So if you have plus plus, then you're going to have a positive factor. If you have a minus plus, then inside the factor it'll be x minus that. So you can have a plus or a minus, it just depends on the question. Those are both okay. All right, so I'm going to have you do this one question with me. I have a perfect square trinomial on the left side here. So just on the left side, I'm just going to cover up that 25 for 1 second. On the left side, can you think of two numbers, if you'd multiply them together, you get 36, add them together, you'd get 12. 6 and 6. Okay, now you can skip this step if you want, but this would be x plus 6 times x plus 6, or the whole purpose of doing this, you have x plus 6 squared. Okay, if both the factors are the same, we can squish them, and then I can get rid of them by taking the square root. So just for this particular example, I just had a little perfect square trinomial on the left side. We can just get rid of this real quick. Just take square root of both sides. Now, I'm writing too big. I'm sorry, guys. So x plus 6 equals, what would you write for square root of 25? Plus or minus 5. Don't forget that's two answers because we introduced the square root into the problem. Okay, now we'll be able to simplify this here in a second, but I've got to move this 6 away from the x. It's positive, so we're going to subtract it. What I would always tell you to do, just put the negative 6 right after the equal sign, plus or minus 5. And then, okay, if the 5's got an I attached to it, we're done. If it's got a radical attached to it, we're done. But we don't. We just have a plain number. So I'm going to do negative 6 plus 5, and I'm going to do negative 6 minus 5 to get my two answers here. So negative 6 plus 5 would give me negative 1. Negative 6 minus 5 would give me negative 11. So those are my two answers. If we plug those back in for x, that would make that equation true. Is anybody having a question? Bless you. Okay, now, this problem had a perfect square trinomial in it, so it was easy for us to make the factors. If you don't have that, you can create that, and it has to be of this format. I'm not going to give you guys any that aren't, but if you're going to do completing the square, it has to start with an x squared. The x squared cannot have a number in front of it. It has to just start with x squared. You can't do this if the a value is anything other than 1. Okay, now, here's how you complete the square. I call this the magic number. If you're in this format, x squared plus bx plus c, the constant term, we're going to make sure it's this number. Has to be the b value, whatever that is, divided by 2, and I'm going to just put parentheses around that, squared. I call that the magic number to complete the square. So if we don't have a perfect square trinomial, we can make one. And all you have to do is identify the b value. So it's just whatever's attached to your plain x. Divide that number by 2, and we're going to square it, and that'll give us a perfect square trinomial. Okay, so we're going to come down here and do this for these problems. So maybe we're going to do this for these problems. All right. If I just give you x squared plus 20x, what would you tell me the b value is in that situation? The 20, right? Okay, here's all you have to do. 20 is the b value. To complete the square, I'm going to fill in this little blank. I'm going to take 20, I'm going to divide that by 2, and I'm going to square that. Now, 20 divided by 2 is 10, right? And what do I get if I square 10? 10 times 10 is 100. I know you know this. Okay, now this is what, right here, this is what I would add into that expression to make that a perfect square trinomial. Okay, now let me ask you this. What two numbers, when you multiply them together, give you 100, and you add them together and you get 20? 10. Okay, so this, and if you want to just go ahead and squish it, that's totally fine, but this would be factored form x plus 10, which I can write as x plus 10 squared. Now, what I want to show you here, and I promise this is true every time, when you do your b value divided by 2, whatever you square, so like I squared 10 here, that is going to be the number that's in the factor with the x. Those will always match if you do this correctly. So whatever you square, that's going in the factor with the x. All right, let me show you this next one because this was positive, right? This b value is negative 8. All right, so I'm going to do my b value, which is negative 8 divided by 2 squared. Now, negative 8 divided by 2 is negative 4. Whenever you do these problems, you're always going to square the number to get the value to add. It will always be a positive number that you add to both sides of the equation when we actually have an equation, but it will always be positive. All right, so negative 4 squared is positive 16. That's the number that you would use to complete the square. But I promise you, whatever you squared, so here I squared negative 4, that is going to be in the factor with the x. And if you think about it for a second, multiply to get 16, add to get negative 8, it'd be x minus 4 times x minus 4, or the entire purpose of doing this, x minus 4 squared. And so I squared negative 4. That is what is in the little parentheses with your factor with x. Now, the reason I'm emphasizing this is because of this last question here. Sometimes the b value is maybe an odd number, and these are not bad, but this is why I thought you wanted to maybe grab your calculator today. So for this last question, my b value is odd. These other two, one was positive, one was negative, but they were both even. If it's odd, my b value here, negative 3 divided by 2 squared, I can't actually divide that like I did on the last two questions. You can still square it though. What you do is just square the top. So negative 3 times negative 3 would be 9, and you also square the bottom. 2 times 2 would be 4. It will always be a positive number. This 9/4 would be what I would add to both sides to complete the square. But if you remember what I just told you, I promise, whatever you square, I squared negative 3 over 2, that is going to go in the factor. So this would be x minus 3 over 2 squared would be the factored form. If you can remember that, especially if you get a question where you're working with a fraction, whatever you square, that's your factor. Just remember that. That'll help you, especially if you have to work with a fraction. Is anybody having a question? Okay, now I'm just going to do a couple examples with you guys on the back. Now, I have the entire process of what I'm going to do written at the top of the page. So if you want to go back and read this, you can as you're studying or whatever, but I'm going to go through and just do these questions with you guys here. Now, completing the square can be used to to solve any quadratic equation. You can't always factor, you can't always use square roots, you can't always graph. You can always use completing the square, but your a value has to be 1 to do it. So you got to keep that in mind. So I'm not going to give you any problems that start with anything other than a plain x squared, but that a value has to be 1 to do this process. So what you're going to want to do, you're going to want to have your x squared and your plain x, those two terms on one side, which I already have these kind of set up in that format. So do x squared plus 8x. Here's what I'm going to do. I'm just going to add like a little blank space so I can complete the square, just like we were doing in the last couple questions. The main difference here is on the back side, we've got equations here. So if we're working with an equation, if I add that magic number in to complete the square, if I add it to one side of the equation, I have to remember to also add it to the other side of the equation. That way we'll keep our equation balanced. So that's the main thing that's different from what we did on the front. We're working with an equation, so we're going to have to add that number to both sides. Everything else works the same. You're going to take your b value. For this question, it's 8. I'm going to divide that by 2 and square it. Now, 8 divided by 2 actually just ends up being 4. So whatever you square, I'm going to square 4 here. That's going to be my factor. But what I actually want to add to both sides is what I get when I square that. So that's going to be 16. Okay. Now, here's the deal. On the left side, what we have should be a perfect square trinomial. Multiply to get 16, add to get 8. If you want to skip this step, you can. I'm just going to write both factors real quick. X plus 4 times x plus 4, or the entire purpose of doing this, they're the same, so I can squish it together, x plus 4 squared. And then notice again, if you want to, whatever you square, That's what's in here with the x. That's what's in the factor. Now, the other side, we're literally just adding numbers together. So 20 and 16 is 36. And this is super nice for us because once I get that set of parentheses, that's what we want. We're just going to get rid of it by taking a square root. Now, on the left side, I just get x plus 4. And you got to remember, we put the square root into the problem, so I got to have my plus and minus. What's your square root of 36 going to give you? 6. All right, so this will be actually kind of similar to that very first question we did today on the notes. I'm going to move the 4 to the other side by subtracting it. So I have negative 4 plus or minus 6. Now, if that 6 has an I, we're done. If it has a radical, we're done. It doesn't, so we're going to have to do a little bit further. So if I do negative 4 plus 6, I get 2 as one of my answers. If I do negative 4 minus 6, I get negative 10 as one of my answers. So if you can actually add or subtract, go ahead and do that. My two answers for this question, I got positive 2 and negative 10. Both of those are real numbers. All right, now, this guy's going to be a little trickier because I'm going to have an odd b value. So we're going to work with some fractions here. I'm just going to tell you to grab your calculator, and it can be graphing or scientific, it doesn't matter. I'm just going to show you a little shortcut. So I'm going to set this up the same way. I want the x squared and the plain x, those two terms on one side, and I'm just going to put plus, and I'm going to make a little blank spot so I can complete the square. If that b value is odd, like it is for this question, what I'm going to add there is going to be a fraction. All right, now the other side is going to be negative 9 plus whatever the number is we're going to use to complete the square. So to save some space, I'm going to write my magic number up here. So my b value is negative 9. I'm going to divide that by 2 and square it. Now, I can't actually divide negative 9 by 2 and get a nice number, so I'm just going to leave that as a fraction. If I square the top of that, I get positive 81. If I square the bottom of that, I get 4. Not negative 9 times negative 9, positive 81, 2 times 2 is 4. So what I want to add to both sides, 81 over 4. Okay, now, I promise. Whatever you square, that is going to be in the factor with the x. So I squared negative 9 over 2. So on this left side, my factored form, I'm just going to write x minus 9 over 2 squared. Now, on the right side, I'm going to grab my calculator to help me do this just real quick. So I'm going to take negative 9, and if you're using a graphing calculator, make sure you use your negative key. Now, I'm going to add, and I'm just going to use the little parenthesis keys above the 8 and the 9. So I'm just going to put parenthesis 81 divide by 4 and then close the parenthesis. Okay, once you hit enter, that'll give you a decimal. And I know you guys could probably do this by hand, but I'm just going to use my calculator to do this. What you want to do to just have it, you want it as a fraction. To do that, it's like 3 buttons you're going to push. Just hit math, that's one button. It's the fourth button down here on the left side. Just hit math, and then we're going to push the enter button twice. Just enter, and it'll give you a fraction. So this is going to be 45 over 4. All right, now the reason you want a fraction here, when I take square root, you can take the square root of 4. It'll always have a 4 on the bottom of this if you did this correctly. So you can always take the square root of 4, that's going to be 2. And shoot, let me break down the 45 just real quick. So on the top, I'd have 45 under my square root. Biggest perfect square that goes into 45 is 9. Or if you guys want to do a factor tree, do a factor tree. But that's going to end up being 3 radical 5. The bottom of that fraction is just going to be 2. All right, so on the top here, I'm going to put my plus and minus so I don't forget. It'd be 3 radical 5 over 2. That would be the simplified form of that square root of 45 over 4. Now, on this side, I've just got this x minus 9 over 2. The nice part of this, and this will work out this way every time, I'm going to add this 9 over 2 to the other side. Now, do you guys notice both of these have a denominator of 2, right? So they're a common denominator. I can actually add them together. So here's how my answer is going to look. I'm just going to have 9 And then I'm going to do that plus or minus 3 radical 5, and the whole thing is over 2. They will always have a common denominator. I know it's a little annoying to work with the fractions, but it will always be a situation where both denominators are 2, and then you can actually go ahead and combine them together into one big fraction like that. Is anybody having a question? All right, both of these, this was an even number, and we had real answers. This was an odd number. These are real answers, even though they've got a radical in them. They're real answers. I don't have any I involved. What I'm going to do in the last example with you guys is just show you what it looks like if we have an imaginary solution. Both of these will have imaginary solutions. I'm going to do exactly the same way. You want your squared term and your plain x on the same side. I'm just going to add a little spot for us to complete the square so we can get a perfect square trinomial and get our factors squished together. You're going to take your b value. This guy, the b value is going to be 12. Just whatever's in front of your x. Divide by 2 squared. For that question, it'll be 6 squared, which will be 36. So we're just going to add 36 to both sides of that equation. On the left side, the whole purpose, I've got a perfect square trinomial. So multiply to get 36, add to get 12. It's going to be 6 and 6. I promise whatever you square, which was 6, is going to be in the factor. So this guy is x plus 6 squared in factored form. The other side, this is actually also nice for us because it's going to be a perfect square in imaginary land. Negative 40 plus 36 is negative 4. So I've got my factors squished together. We can take a square root and get rid of that. And so I'm going to have x plus 6 equals plus or minus. What would you tell me for square root of negative 4? 2i. So just put a plus or minus 2i, and you'll have one more step here because we won't be able to combine any like terms here. So I'm going to subtract the 6. This will be negative 6 plus or minus 2i. Excuse me. You can't go any farther than that because I can't add the real number and the imaginary number together. Is anybody having a question? All right, now I know this is a little annoying. If the b value is odd, we're going to end up working with some fractions, but just go ahead and grab your calculator. We can do that. So we're going to have x squared plus 7x plus, I'm going to leave a little spot to complete the square. And then on the other side, I have negative 16. And I know I'm going to complete the square on the left, so I'm going to put a little blank so I can complete the square on the right and add that number to both sides to keep my equation balanced. All right, now, I know it's a little annoying to work with. You're going to take your b value, which is 7, divide by 2, and square that. I can't actually divide 7 by 2. So what I'm going to do, just leave it right like that. Square the top, which is 49, square the bottom. The bottom will always be 4 because it's the b value divided by 2 every single time for that magic number. So the bottom of that fraction will always be 4. So I'm going to add 49 over 4 to both sides. On that left side, we're just going to put it in factored form. So I promise, especially if you're working with a fraction, this is good to remember. Whatever you square, we squared 7 over 2, that's going in my factor with the x. This was positive, so it'll be x plus 7 over 2. For the other side, I'm just going to grab my calculator. I'm going to do negative 16 plus, and then I just use the little parenthesis keys. If you guys have a scientific calculator, you can use the fraction button if you want to. But I'm going to do 49 over 4, hit equals, and then I'm just going to hit math and enter in that bottom right corner twice, and that'll convert that to a fraction for me in lowest terms. So this would be negative 15 over 4. Now, the only thing I know here, when I'm working with a negative number, I'm going to take a square root. We're just going to have an I involved. It's no big deal. We're just going to take square root of both sides. Now, on the left, the square root and square root just cancel each other out. So I still have x plus 7 over 2. I just don't have the parentheses or the squared. On the right side, this is actually a little nicer than the question we just looked at above. So on the top of the fraction, 15 is not divisible by any perfect squares. So we're not breaking anything down here. but I have a negative under the square root. So on the top of that fraction, don't forget your plus minus symbol, I almost just did. Just put an I, and then the 15 would stay under the square root. The bottom of the fraction is always going to be 4. So you can always take the square root of 4. The bottom of the fraction, square root of 4, is just 2. And the reason that's nice is because whenever I move this fraction from the other side, they both have a denominator of 2. So I'm going to subtract 7 over 2 from both sides. So when you do that, we're just going to put the plus and minus symbol in between. The top of the fraction would be negative 7 plus or minus that I radical 15, and then the whole thing is over 2. They can always, if you're working with the fraction, I know it's a little bit tricky, but they will always have a common denominator if you're doing that correctly. And then you just move the 7, so I subtracted it, so that's why that started out with negative 7. And I just did plus or minus that I radical 15, the whole thing is over 2. Is anybody having a question?